This is a video demonstrating showing the water loss setup. So first off, there are two power switches. There's one on this side. This is for the EHD system. And then on this side, this is for the chiller and coil. They are fed into each other by daisy chain. The first thing you would do is turn on the dehumidifier here. I switch this knob and then switch this to make sure this is on manual. Underneath it is the chiller. You turn it on by the switch to the left. A little demonstrating what's going on. This is the wet, hot air coming out of the desiccant dehumidifier, and that's being fed outside. And then this is the inlet. This is the outlet, and it goes into a chiller coil. And then there is a temperature and humidity sensor before that coil, and then one after. Inside the testing chamber, we have an electrode which is suspended upon the grounded conductive plate here. The electrode is fed and is loose. You can undo it and put it at different heights along this due to the copper rail going in the inside. So it doesn't matter on the height. So you can change it in increments of 1 centimeter. Underneath that, like I said, is the grounded conductive plate, and that is fed to ground by these red banana plug clips in the back. There is one here. So what you would do is you just plug it in. And then there's also one on the other side. On the front side is for the high voltage. There is a plug here for high voltage. You would plug it in the same way. And that feeds this copper rail and then the copper wire going up through it. There's also one on the other side. They are the blue connectors. Underneath it is a spacer to lift up on the conductive plate so we can get a mass reading. And then they scale protected by a Faraday's cage. On the back side is the two connections for ground. So depending on which plug you pick on the inside, you connect the alligator clip to it. This is also the ground for the scale. So when you are ready to begin a test, you go to the computer. The program is located in the C drive underneath EHD application 424, and then the executable for it is main, and you would open up the program. The program looks like this when you open it up. The first thing you would want to do is go over here to edit the test parameters. That brings up a dialog box. This is where you select all the test values from the different sensors that you want it to collect, and then also give it a test name, a test duration in hours and minutes, and then the sample rate. Once you click OK, that will open up a dialog box for the voltage scheduler. This is where you add a schedule to the voltage supply. First thing you do is make sure that remote is selected, and that will bring up a dialog box also, and it will be asking you to make sure that the switch for between manual and remote will be switched. That is this top switch here. Make sure that is on remote before starting a test, or the voltage supply will not be seen by the program. To add a new iteration of the voltage supply, you would click Add New Item, and this is where you add the start time, end time, and the voltage duration of this segment. And you continue to add those till you get your desired voltage supply schedule. And then when you're ready to begin a test, first you would do is zero the balance with nothing on the plate there, and then after you zero the balance, you can put your sample on that plate. And then close the door and then start test. Once you start a test, it will begin to populate the test data tab here with all your selected readings. Once that is finished, once your test is finished, everything is saved in the C drive as well, underneath EHD, and then test. And this is the setup for the high voltage supply with the power switch on the front. And that is a typical water loss test. To prepare for a heat transfer test, you would take out the slide out of the chamber for the water loss test, and then you can take off these rails due to Velcro, and you can switch it over to the hot plate test, which is this slide here. So you can take that and then suspend the electrode across, just snap those in. Once that is in place, you can take out the spacer for the water loss test, and then you can take this new slide and put it in the front door of the testing chamber. And then you can plug it in to the high voltage path there. This is the hot plate. The hot plate will go in here, and the wires will be fed down below. This is with the hot plate inside. And then underneath, this umbilical cord has a couple different cables for the hot plate. This RS-232 connection would plug in this back DAC system that is labeled hot plate. And then there is also a ground that would make a connection with the past ground connection going to the high voltage power supply. So there's only one ground for the hot plate test, and it would be for the hot plate. And then also on the connection with the RS-232, there's this system. You would take the two alligator clips from the blue power supply and then plug them onto these connections. Just like so. This would be how you make the connection from the power supply to the hot plate. You clip it on those two metal rods. And then to begin the heat transfer test, you would turn on this power supply and then adjust the voltage until it is 14.5 volts. That is generally what we found to get the hot plate to 50 degrees Celsius, even with the airflow going over the chamber. So you might have to experiment and see differently, but 14.5 was our lucky number. And then from the program side, to begin running a test, it would be the same exact way, except you would not have to zero the scale anymore. So you would go into Edit Test Parameters. Since I don't have it plugged in, it will not show it for me, but for the heat transfer box here, this would not be grayed out anymore, and you would be able to select heat transfer. That would take all the readings from the thermistor underneath the hot plate, the thermistor underneath the polystyrene foam, the infrared sensor, the surface temperature thermistor, and then the ambient temperature sensor over here. It takes all those values to calculate the heat transfer coefficient, and then so again, you would set up your test by test duration, test name, just like before, click OK, do your voltage scheduler, just like before, and then you are able to run a heat transfer test. So that is a quick demonstration of the two different tests, and the outlet for the drying chamber gets vented outside through this ductwork, and there's actually a damper on the outside of this to not allow backdraft into the system.